In this unit, we're going to learn about atoms in the periodic table. I find that quite often people know something about the periodic table and they know something about atoms. For instance, I don't think it surprises you that everything in the world is made up of these teeny tiny little objects called atoms. Doesn't matter whether it's a table, gold bar, rain, or for that matter, air, right? All things are made up of atoms. Even you are made up of atoms. So if you know something about atoms, we want to do a little check to see what you already know. Like for instance, did you know this little fact, that everything in the world is made out of just 88 types of atoms? Now a lot of times people are like, hold on just a minute, I know something about atoms, and I've seen a periodic table. Can that possibly be true? Well, we're going to look into that today. So our goal is to know how the periodic table organizes these naturally occurring 88 atoms that everything is made of. So periodic tables can look a lot of different ways. Some are more colorful than others. Some are stretched out a bit more. Some are flat out bizarre. I don't know if you've ever seen that one or this one. But their goal is always to organize information about atoms. And there really are only 88 naturally occurring atoms. Now, if you look at this, you might contest that right away, because if you're saying, okay, I think these numbers are counting the number of atoms that are in the world, and you come up here and surely it goes beyond 88, and you would be right. It does go beyond 88. But most of these that are beyond 88, of course, are not naturally occurring. They've been made in lab, which means if you go out and dig in the dirt, you won't find them. So let's do a little exploring of the periodic table today. Let's find out what you already know and maybe learn some new things. Maybe you're curious to look in here and see some things that you maybe have heard about but always wondered about. So let's start with the first one, which is I said there were 88 naturally occurring elements, and that number that they're organized by is referred to as the atomic number. Makes sense. They're atoms, they're numbered, atomic number. Sounds great. So let's find out what you already know. In the next question that's about to come up, I'm going to ask you to click on a link that will give you access to a periodic table, and you may want to save that periodic table because you're going to be using it a lot in this unit. But you'll notice it has symbols and names for each element. If we go back and look at that last periodic table, you see, there we go. We have a symbol and a name, and of course its atomic number. So I want you to find 5 elements that you've already heard of. You already know them. Don't pick ones that you've never heard of. So write the symbol, name, and atomic number on a piece of paper. So you'll need to do this, you'll need this piece of paper to be accessible for the next few questions, so don't throw it away. You really do need to write it down. And what it should look like, let me give you an example. If I sort of grab the corner of the periodic table, one of the elements that I've heard of is oxygen. I've heard of oxygen. It's all around us. It's what we need to breathe. So you can't do oxygen because this is mine. This is my example. So the element name I'm going to write on my piece of paper is oxygen. The symbol is O, and the atomic number is 8. All right, so you're going to pick 5 that you already know and do the same sort of thing and start creating a list. Now, for each one of those elements you wrote down, I want you to think about what they look like. In other words, what is their state, we say in chemistry? Were they a solid, like a table, a liquid, like rain, or were they gas, like air? Now, when you fill out your table, I want your table to look kind of like this. So you're adding an extra column over here, which I want you to write the word state, because when we say what is the state of that element, we mean is it a solid, liquid, or gas? All right, now what we're going to do is we're going to take the information that you already have and we're going to look at some other elements that maybe you haven't heard of. Like for instance, did you know that in Colorado, we are a state that mines a lot of molybdenum, which is a type of element? Let me show you.
A mining company's proposal up in the mountains could potentially impact our water supply down here in the metro area. It's focused on a metal called molybdenum.
Now, the Climax Molybdenum Company wants to change restrictions so it can release more of the metal into the water. 9 News reporter Anusha Roy explains.
There's a reason people choose to live in Leadville.
And I fell in love with the environment here, and I'm hoping I can keep loving it.
And that's the very thing some believe is under attack.
I mean, I was really horrified.
The Climax molybdenum mine is about 15 minutes away. It can be used to strengthen steel and iron for anything from ships to cars. But when it's mined, some of it is released in a 10-mile creek. And now Climax wants to change state restrictions to allow roughly 42 times more to wash away. 10 Mile Creek flows into the Dillon Reservoir, and Denver Water says from there goes to the South Platte River watershed, which provides around 80% of Denver's water supply.
First thing I thought of was all the people that won't even know about this.
Climax says the current standards need to be updated based off of newer studies by the International Molybdenum Association. It's also questioned the need for restrictions. The EPA doesn't have any current rules, and Climax says there is a lack of evidence for health impacts.
And I'm just blown away that this is even being taken seriously.
Small amounts of molybdenum is actually good for people, but the Rocky Mountain Poison Center says too much can cause nausea and abdominal pain. But how much is too much is hard to say.
I mean, I don't know how I'm going to feel comfortable drinking water.
The Water Quality Control Commission says there's not a lot of data about the impact of molybdenum on humans.
What about wildlife? What about flora, fauna?
In a statement, Climax said it is not planning to discharge more molybdenum, but when we asked why they want the levels changed, they wouldn't explain further, but said science does not back up the current rules. In their proposal, though, the company says if restrictions were eased, it would save money on water treatment.
So molybdenum, obviously very important in Colorado, is an element that's a lot more rare than the oxygen example I gave, or probably the 5 elements that you came up with. So what we're going to do is we're going to explore some elements that maybe you don't know something about. So molybdenum could be one, but I want you to find some others here, because there are a lot on the periodic table that you could use. And when you find one that you're like, hey, I don't know what that is, write it down, and I want you to record, well, let's do molybdenum as an example. So molybdenum is right here. Its name, I'm going to spell carefully because that's a hard one to spell. Its symbol is MO. Its atomic number is 42. And its state, well, I don't know what its state is yet. I don't know if it's a solid, a liquid, or a gas, because they didn't really say in that story. And we're going to figure out the state in the next exercise. You don't have to do that here, so you can leave this blank. But I want you to find 5 other elements on the periodic table that you've never heard of. And I want you to write down their element, symbol, and atomic number. Okay, so how are we going to figure out the state of those elements that we've never heard of? Well, periodic tables, as I told you, come in a lot of different colors, and a lot of times it's because they're trying to tell you something. So I took this periodic table, which I'm going to link in the question I'm about to ask you here, and what this periodic table does is it labels things as solid, liquids, and gases. But of course, I took off the legend. It told you what green, yellow, and blue were. But I have a feeling you can figure it out. So I want you to go back to the elements that you knew, that you were confident about, those first 5. You had a feeling for what their state was, whether they were a solid, liquid, and gas. And I want you to find out where they are on this periodic table. Are they in the green area or the yellow area, or were they blue ones? And I want you to figure out which color you think represents the solids. Is it green, yellow, or blue? And which color do you think represents the liquids? Is that green, yellow, or blue? And then, of course, which ones are the gases? And once you know that, you'll know the legend. And I want you to write down for all of your elements that were new, that you had never heard of, I want you to write down what this chart says they are. See, for instance, I can see molybdenum is green, but you've got to figure out, does green mean it's a solid, liquid, or gas? And then fill it out for your 5. All right, great job. Now we're going to finish off with just a couple of questions, since today you learned about element names, you learned about the symbols, you learned how to find the atomic number, and you learned to figure out whether it was a solid, liquid, or gas using a different periodic table like this one. So we're going to do some follow-up questions, and I want you to answer those questions based on what you learned today.